Hey guys, it's Off by One here, and today we're going to be solving combination sum 4. In this problem, we're given an array of distinct integers, meaning that we don't have any duplicates, and the array is called nums, and they give us a target integer called target, and they want us to return the number of possible combinations that add up to target. So as we can see here, we're given an example where the nums are 1, 2, and 3, and our target is 4. And they tell us that there's 7 different combinations that can lead to this. And we can also see that we can reuse the same combination as long as it's in a different sequence. So how can we break up this problem into smaller subproblems that we can solve? So let's see, if our target is 4, let's say we use our num of 1, so we subtract 1, and now we have 3. So now the real problem is going to be, how many distinct ways can we make 3? Well, we can have 1, 1, and 1. 1 and 2, 2 and 1, 2 and 1, and then a 3. And that's 4 different combinations. Okay, well, what if we subtract 1 from 3 this time? How many combinations make up 2? Well, we know that 1 and 1 make up 2, and just the number 2 makes up 2. So that's 2 distinct combinations. So now we go to 2 minus 1, we get 1, and there's only one way to make 1, and that's just with that. And if we add up all of these, we get 7 different combinations to make up 4. So let me show you what I mean using a better drawing. So I've rewritten a problem here, and we have the same numbers and the same target. So what we're going to do is start with our target, and then make some branches. And on this branch we're going to subtract 1, this one we're going to subtract 2, and this one we're going to subtract 3, so that way we can see what leads us to a value of 0. Because if you get a value of 0, then that means that's a valid combination. And let me just show you what I mean. So here we have 4 minus 1, that is 3. Here we have 4 minus 2, that is 2. And 4 minus 3 is 1. And now we do the same thing. We branch off from each one of these, and we do the same thing. Subtract 1, 2, and 3. Well, we can see here that 3 minus 3 is 0, so that's a valid answer. And 3 minus 2 would be 1. 3 minus 1 would be 2. And now we do it again. So 1, 2, and 3. So this is invalid because 2 minus 3 would be negative. So that's not a valid way to get to 4. 2 minus 2 is 0, so that is a valid way. And then 2 minus 1 would be 1. And then finally we can finish off this tree here by doing it again. 1, 2, and 3. 1 minus 3 is negative, so that's not a valid way to get to 4. And same thing with 2, and then 1 minus 1 would be 0. So we can see that if we branch off here, we have 3 different ways to get to 4. Actually, I forgot to do this one here too. So let's see. We subtract 1, 2, and 3. So these 2 are invalid, and this one is equal to 0. So we have 4 ways to get to 4. And as you can see here, for 2, we already calculated 2 over here, and we know there's 2 different ways to get to that. So we're just doing repeated work here, but let me just go through it so it makes more sense. So if we subtract 1, 2, and 3, this is invalid. This would give us 0, and this would give us a 1. And now we branch off again. 1, 2, and 3. This is invalid. This is invalid, and this would give us 0. And now we have this 1 again. So let's just finish that off. We have 1, 2, and 3 for our num values, and these 2 are invalid because they give us the negative, and then this would be 0. So as you can see, we're doing the same work over and over again, and that's how we know that this is going to be a dynamic programming problem. So what do I mean by that? Well, like I said earlier, we already used this 2 before here, so we don't have to redo the work over here. And to do that, we can just store the result of 2 in an array. Let's call it result. And whenever we have a 2 again, we can just access result at 2 and see how many different combinations there is to get to 4 from there. So let's just look at this 2 here so we can see how many different combinations we can use to get to 4. So as you can see, if we go 2, 1, and 1, we end up getting to 0 here. So that's a valid combination. And then if we go from 2 to 2, we get to 0 here. So there are 2 valid combinations to get to if we have a 2. So here I've rewritten my array that we're going to use to keep track of how many different ways we can get to that number. So next up, we're going to solve for 1. So here we have a 1. How many distinct ways can we get to the 0? Well, we can see there's only one way, and that's by using 1. So we have a 0 here. So we can just initialize this to 1. Okay, well, what about for 3 here? Well, if we start at 3, then we know there's 4 distinct ways to get to the 0 because we hit it 4 different times. So we can just initialize this to 4. So in total, we have 7 zeros, and we know that just from looking here. So we can just initialize our result at 4 equal to 7. And we would return this in the problem, but now we need to come up with some kind of algorithm to be able to calculate this. Before getting to that, there is one last thing we have to do, and that's to initialize our base case. So we would have result at 0. So what do we want to set that equal to? Well, if we think about it, we should set it to 1 because whenever we access index 0, that means we hit the 0. So we want to return a 1 if that ever happens. So for example here, if we're trying to calculate our result at 3, we can do result at 3 minus 3, which would be equal to result of 0. And that should return 1 because we want to add that to the result of 3. So we can say result of 3 is equal to result at 3 minus 3 plus result at 3 minus 2 plus result at 3 minus 1. And as we can see here, result at 3 minus 3 is 0, result at 3 minus 2 is 1, and result at 3 minus 1 would be 2. So if we add 2 plus 1 plus 1, we do get 4. And I know this is really messy, so let me clean this up. So here I've rewritten the array, and I pointed out the indexes just to make things a little clearer. And I'm going to name the array result to make it easier to access in our pseudocode. And also I want to point out that these indexes are the target. So for example, if our target was 1, we can say there's one distinct way to get to 1. If our target was 2, there's 2 distinct ways. If it's 3, there's 4 distinct ways, and so on. So now let's get into our pseudocode. So what do we want to do? Well, we know we want to iterate through every single index in result because that's the only way to calculate the final target. So we want to find the number of distinct ways we can get to 1, 2, and 3, and then we can find 4 from that. So let's just write that. So for all indexes in our array, well, what do we want to do? So let's say we start at this point here. Well, we want to check all of these numbers as well to see if they're valid and see how many distinct ways we can make up 1. So we can also say for all nums. Okay, well now what do we want to do? So let's say we're checking for index 1. So let's just do our decision tree again. So if we do 1, 2, and 3, we can see that 2 and 3 don't produce valid results. We put X's here, and this gave us a 0. And the reason these were invalid is because 1 minus 2 would be -1, and 1 minus 3 would be -2. And those wouldn't be a valid index in our result array. So what we can say is that if I minus our number is greater than or equal to 0, then that means we have a valid number and index. So now that we have that, what do we want to do? Well, we know we want to update our results at our current iteration, but what do we want to update it to? Well, again, let's take a look at another example. So let's say we're at 3. At 3, if we do 3, 2, and 1, here we'll get 0, and here we'll get a 1, and here we'll get a 2. So we want to add the result at 0, result at 1, and result at 2. So I guess we could say here we want to add our current result plus the result at I minus our number. So in case it's not clear, the reason we do result at I minus number is because we want to calculate result at 3 minus 3. So when we use our number 3 here, we want to see how many distinct ways we can make 0. And like we said earlier, that will be 1. And then we want to do our result at 3 minus 2. So now, how many distinct ways can we calculate 1? Well, if we look here, we see that there are only one way to calculate 1. And then for result at 3 minus 1, we're trying to calculate how many distinct ways there is to get to 2. And we can see that that is 2. And if we add all of these together, we get 4. So that's going to be it for our algorithm. And then at the end, we can just return this last index over here, since that's a target we're actually looking for. So for our time complexity, we're iterating through every index in the array, which is of size target. And we're also iterating through every number every time we go through one of these indexes. So our time is going to be O of n for the target times m for our numbers. And then for the space, we're only using the result array, and that's of size target. So we can just say the space is O of n. Now that we have that, let's get into the code. So I know that was a lot of explaining, but the code is actually pretty simple. So first we want to initialize our array, and we want to initialize it with all zeros for a length of target plus 1, because we want to have room for our base case. And we want to initialize our base case to be equal to 1. And then from here, we just want to iterate for I in range of 1 all the way to target. So we're going to have to do plus 1 for that. And the reason we start at 1 is because we already have our base case here, and there's no need to go through it. So for every index, what we want to do is check every number and see if it's valid. So for num in nums, we want to check if I minus that num is greater than or equal to 0. And if it is, then that means it is a valid number, and that'll produce a valid index. And now we just want to update our result array at the current iteration to be equal to the result at I plus result at I minus our number. And this can actually just be simplified to this, just to make it a little neater. And that's it. After that, we can just return the last index in our array, which would be index target, and that should work. So as you can see, this code is pretty efficient, and now I'll go through the code manually. So I've written our example here. We're going to be using nums, and our nums are going to be 1 and 2, and our target is going to be 3. So pretty similar to the example we've been doing, but just a little shorter to save time. So initially, we want to set our result array to all zeros for a size of target plus 1. And as you can see here, the size of this array is 4, and our target is 3, so that makes sense. So that's checked off. And then our result of 0 is equal to 1. So I've already initialized that there, so we're good there. And now we just want to iterate through all indexes. So we're going to start at I equals 1, and from there we want to check for every number in our array nums, we want to check if this would be a valid index. So I minus num. Well, our current num would be 1. So I, which is 1 currently, minus 1 is equal to 0, so that is valid. So what do we want to do here? Well, we want to update our result at I to be equal to the current result plus result at I minus num, meaning that we want to add result at 1 minus 1, which is index 0. So currently it's 0, and 0 plus 1 is 1. And now we check for number 2. Well, we know that 1 minus 2 is negative, so we can just skip that and go to the next iteration. So now we're going to be at I equals 2, and we're going to check every number in our array to see if it's valid. So let's start with 1. So 2 minus 1 would be equal to 1. So that is greater than 0. So what we want to do is update our result at 2 to be equal to the current result plus the result at I minus num. And I minus num would be 2 minus 1, because we're currently looking at our first number, and that would be result of 1, which is equal to 1 here. So we want to update this to 1, and now we go to the next number, 2. So let's see, 2 minus 2 is equal to 0, so that's a valid number. So now we want to update our result array to be equal to our current result plus result at I minus num, which would be result of 0. And as you can see, result of 0 is 1. So we want to add 1 plus 1, so that would give us 2. And now we can go to I equals 3. So now our I is equal to 3, and now we want to iterate through the nums array. So for nums in num, we want to check if it's valid. So let's start with the 1 here, and let's see. Result of 3 minus 1, well, this is positive, so we're good here. And now we want to update result at 3 to be equal to the current result at 3 plus result of I minus num. And if we're doing 1, that would be result of 2, so we want to add 2 to 0, and now this is going to be 2. And now we go to our next number, 2. So let's see, 3 minus 2 is equal or greater than equal to 0, so we're good here again. And now we want to update our result at 3 to be equal to the current result at 3 plus result at I minus num. And result at I minus num would be result at 3 minus 2, which is result at 1. And we can see that that is 1 there. So we would add 2 plus 1, and that would be our new value at 3. And then after that, we just return the result at target. So result at index 3 is 3, and that is correct. There are 3 distinct ways to make 3 by using 2, 1, 1, 2, and 1, 1, and 1. If this video helped you in any way, please leave a like and subscribe. Thanks for watching, and I'll see you in the next video.